Hey guys, I hope you had a great weekend. I'm going to cut straight to the topic here. This is going to be kind of long, but we're going to try to make it as fast as possible. We are starting a new chapter. This lesson, like I said, is going to be a little on the long side, but try to stick with it. You get to use the notes on the tests and the quizzes, so it's in your best interest to make sure that you make it all the way through it. So the first thing we're going to talk about is just triangles in general. There are two ways to name them or to classify them. So you can name them by their angles and you can name them by their sides. So there's like two sections of these. So the first one is equiangular, and that just means you have three congruent angles or three angles that are exactly the same. And in the picture, they will show you that all three angles are marked congruent with these little arcs, or they'll give you a number in each angle that shows that they are all the same. The next type is acute, and acute just says that all three angles are acute or less than 90. So in this one, sometimes they will show you a picture where all the angles look small, or they'll give you the numbers for all the angles that are going to be less than 90. But the idea is all the angles are small. The next triangle is right, and that just means it has one right angle. And you'll usually see that one marked with a box in the picture, or it'll say 90, either one. And the last angle name is obtuse, and that one just means that one angle is obtuse, or one angle is bigger than 90 degrees. And in the picture, it'll either say a number or you'll just have an angle that looks really big, and that's how you know it's an obtuse triangle. The next way to classify a triangle is by its sides, and there are three types of side classifications. The first one is equilateral, and just like equiangular, it's just telling you that all the sides are equal. And most of the time, it'll show you with the dashes that all the sides are the same, or it'll tell you with numbers that all the sides are the same. But it could also show you that all the angles are the same, and that would still make it equilateral. The next one is isosceles, and isosceles says you have two congruent sides or two congruent angles. So again, it'll either show you that both sides are the same, or it will tell you that both angles are the same. And the last one says no sides or angles are the same. So nothing matches in a scalene triangle. So it'll either have no marks or it'll give you numbers that you can see that everything does not match. The other big thing that we're going to talk about with triangles today is the triangle sum theorem. And the triangle sum theorem says that all the angles add up to 180. So inside of a triangle, all the angles add up to 180. So for the first set of examples, all we're going to do is classify it by its sides and its angles. So for every triangle, there's going to be two names. And that's the important thing to remember. There's going to be an angle name and a side name. So when I look at number one, I see it has a right angle. So that automatically means this is a right triangle. And then if I look at all the sides, they're all different. So that's what we mean by scaling. Nothing matches in that triangle. When you look at the next one, notice that all of his angles match and all of his sides match. So this one is equiangular and equilateral, and it turns out that if it's one of the E words, it will be both of them every time. And then the last one here, I see the 120, so that automatically means this is obtuse. And then when I look at the sides, do you see you have two 10s, but the 18 doesn't match? So it has two things the same, kind of like you have two I's the same. That's how I always remember the isosceles name, is it's got two things that are marked congruent. All right, for the next section, 4 through 8, we're going to find the measure of angle 1. So notice that these angles are inside the triangle, and we said that with the triangle sum theorem, it says that all the angles add up to 180. So all we're going to do is we're going to take 180 minus 90 minus 35 to give us angle 1 is 55. So we'll do the same thing for number 5. 180 minus 75 minus 54 is going to tell you angle 1 is 51. Again with 6, if we take 180 minus 33 minus 28, we get angle 1 is 119. Okay, same thing with number 7. 180 minus 90 minus 59 tells you angle 1 is 31. Number 8, 180 minus 50 minus 50 tells you angle 1 is 80. So hopefully that made sense. So basically they have to add up to 180. So if I take 180 minus the 2 that we know, we will get the one that we're missing. All right, number 9 is a little bit trickier. So on number 9, I've got two triangles stuck together. We've got one on the left and one on the right. And I want you to look at this one on the left. So the one on the left, do you see how I already know 2 of the 3 angles? So we're going to do the same thing we just did on the last problems. We're going to take 180 minus 27 minus 36, and we're going to get the x is 117. So that's the big step. Now we're going to take these 2 angles. We're going to look at these 2 together, x and y. Now, do you see how x and y make this straight line? And we know a straight line is 180. So we're going to take 180 minus 117, and that's going to tell us angle y is 63. So once I have those 2, we can find z, because now we have another triangle. So we have the one on the right now, and the one on the right, we now have 2 numbers. So 180 minus our 63 minus our 95 is going to tell us that z is 22. So when I write these down, I'm going to have x equals 117, y equals 63, z equals 22. Same idea on 10. So the goal is to figure out which triangle do you know 2 of the 3 angles. So in this case, it's the one still on the left, or the bottom, however you want to look at it. We have the 11 and the 127. So when I subtract those 2 numbers from 180, I get x is 42. Now we're going to use this linear pair, and that tells us to take 180 minus 42, and we get 138. And now we have the 2 numbers on the other triangle, so now we can use this triangle up here. And we do 180 minus the 6 minus the 138, and that tells us z is 36. So we have x equals 42, y equals 138, and z equals 36. So the goal is to figure out which triangle do I know both angles, do 180 minus those 2 angles, then use your linear pair, so 180 minus the angle you just found, and now you have 2 angles in the second triangle. So 180 minus the one you just found and the other angle, and that will give you your last one. So hopefully that makes sense if you follow along. Okay, the last big thing we're going to talk about is the exterior angle theorem. So the exterior angle theorem is talking about an outside angle, like angle 1. And it says I can find the measure of this outside angle simply by adding the 2 inside angles that do not touch it. So as long as we don't use the one right next to it, we're good. So angle 1 is angle 2 and angle 3 added together, and we're going to try that out. All right, so looking at number 11, we want to find angle 1, so that one's outside. We know we cannot use the angle right next to it, so we can't use that guy. So we're going to add these 2 angles together. So 76 plus 52 tells you angle 1 is 128. Now notice 12 is different. So angle 12, the outside angle, is not what we're trying to find. But if you remember, normally we would just add the 2 inside angles that don't touch our angle, and that's supposed to give us our outside angle. So in this case, all we have to do is subtract the one we know, and that tells us angle 1 is 25, because if we take 25 plus 79, we would get 104. All right, we're almost done. So in example 13, we're going to put everything together. It says find the measure of each angle and classify the triangle by its sides and its angles. So we have to figure out what every angle measures so that we can decide if it's acute, right, obtuse, isosceles, scalene. And to do that, we've got to solve for x. Now I know that all 3 angles inside of a triangle have to add up to 180. So we're going to set up an equation that does that. We're going to add up the 2x, the 3x minus 10, and the 110 minus x and set it equal to 180. All right, we're going to start putting those algebra terms together. So we've got our like terms. So we've got 5 minus 1 gives me 4 x's. And you've got a negative 10 plus 110 is 100. And that's supposed to equal 180. We're going to subtract our 100 from both sides. So we get 4x equals 80. And then you're just going to divide by 4. So we end up with x equals 20. Once I know what x is, we're going to plug it in, just like we've been practicing on all the other examples we've been doing. So angle A is 2 times 20, which is 40. Angle B is 3 times 20, which is 60, minus 10 is 50. And angle C is 110 minus x, which is 20. So 110 minus 20 is 90. And then we're going to look at our three angles. So we've got a 90, we've got a 50, and we've got a 40. So none of those match, which means it's scaling. And I have this nice 90 number. So this particular example is going to be right because of the 90 and scaling because nothing matches. All right, this one works kind of the same way except for we don't have to classify it. But I know all three of these have to add up to 180. So we're going to set up our equation. We're going to add up all three angles, and we're going to set it equal to 180. From here, you're going to add up those like terms. So we have a 9x plus 5x plus 11x, and that's going to give me 25 x's. And then I have a 3 minus 2 minus 21, which is a negative 20, and that's supposed to equal 180. Add my 20 to both sides, I get 25x equals 200, and then I'm going to divide by 25 and get 8. And then once I know what x is, I'm done because this one told me just to find x. So I'm finished once I find the x. I don't have to plug this one in this time.